All right. So first, I want to say thank you for inviting me. I'm really looking forward to learning from all of you here in the room. I'm going to start with a very simple story. So I landed here yesterday, and I came from Bay Area, where on Saturday it was 80-degree weather, and people were in shorts and t-shirts. And I landed here, met a friend for dinner last night, and I said, "Wow, I was in summer, and you guys are in winter." And she said, "Oh, this is spring," right? And I did a little, sort of like, oh, but this is sort of the kind of conversations that I find that we end up having with users, right? Where there's a little bit of a disconnect and a little bit of a different context that we sometimes miss. So a lot of what I'm going to talk about today is sort of this duality of user experience, software sustainability that comes in building new software for science. Before I dive into my talk, I think it's a little bit useful to give you the context of where I'm coming from. Berkeley Lab is a Department of Energy national lab and was established in 1931 when Ernest Lawrence recruited a brilliant circle of colleagues from physics, chemistry, biology, engineering, and medicine to solve some of the scientific challenges of that time. So this team science is the essence of what we do today. And the team's actually more diverse than what you see in the picture. There are more women at the lab now in many different dimensions. Our multidisciplinary science teams working together solve some of the global problems in human health, energy, technology, and environment. And in addition to the magnificent views of the Bay Area that we have up from our site, I encourage everyone to come. We also like to boast of our 14 Nobel laureates on campus. So a multi-program research mission is supported by sort of 6 major research areas, which include things like high energy physics, bioinformatics, and things like that. So what we do there is really we work very closely with the sciences. So we have a lot of user facilities like the Advanced Light Source and the Joint Genome Institute and the Molecular Foundry, which are producing large amounts of data, but also have complex software and processing that they manage. So most of our scientific advances, and I don't have to say this to the audience here today, depends on these ability of these researchers to sort of use the high performance computing infrastructure to operate on large scientific data and effectively assume that the software just works. And so how do we make that happen? So the key question that my research group focuses on is how do we enable researchers to effectively and efficiently manage their computation and data? And we look at a number of different problems across workflow and data management. I'm happy to talk about my science, but this today isn't that, right? I have a different talk I would give in that respect. So we work very closely with sciences from different areas, looking at various problems and various software challenges. So how did I get here to be here on the podium talking about the social aspects of software? So back in grad school, and actually Dennis is my advisor, so it was really nice to have Dennis here in the room. I took a HCI class in Indiana University, and I thought it was fascinating, right? Like the fact that, usability mattered and like the way I opened my CD case, somebody should be studying it was super fascinating, but I tucked away all I had learned in the class, went about doing my work. And then I was working as a research software engineer in about 2002 to 2005, 6 or so. And one of the things we built was a North Carolina bioportal. This is a big deal because we built a web interface that supported bioinformatics tools. And we were super excited that we had so many applications now the users could use. The first training session that I was in, there were a lot of users who were effectively running an application, taking the output from the web browser, copying it and pasting it into a notepad, pasting it back into the web browser to run the next application, right? And I just went, why didn't you tell me this? Because we could have just built a way for you to do all of this in the web browser. But that had never come up in our conversations because we had never really said, can you show us how you run your applications? So there was important lessons here. It took me a few more years to come around to it, but knowing sort of how users use it and the work practices around their data and workflow is really super important when we are building tools for them. So move forward to 2012, and we had a computing sciences retreat in Monterey. And we colleague of mine and I were sitting in the back of the room, and we had like report outs from this pre-exercise that people had done where they'd gone to every scientific division and said, what do you want us to do for you as a computing sciences area? And the top 3 on the list always included workflow tools, right? So my colleague and I are sitting in the back of the room and we're snickering because we're like, we've done this. This is a solved problem. We don't need to do this again, right? And so, but something about that day just sort of stayed with us and, nagged us as we came back to work the next week. And, we started having some whiteboard discussions about, why were we failing? Like to some extent, there were thousands of workflow tools, but none of these people believed that that solved their problem. And this is really a significant turning point in my career, because we sort of started thinking about usability and sort of user experience as a part of what we do today. So really what's unique about our group is we take a dual approach to addressing the challenges of scientific workflows, where we, of course, build tools and work very closely with high performance computing systems, distributed systems, but we also work very closely with the people, trying to understand how they use their software so we can do better. So we've looked at user research, and that has been an essence of what we've really built up that team. And user research, gives you a process to verify and validate your intuition about what the user needs, and also convert it into action, right? So a lot of our teams now effectively have user research people who sit in between the R&D team and the users, trying to sort of bridge the gap of what is needed. So what are the realities of science? The realities of science is it's really messy. They don't actually fit into nice directed acyclic graphs, which is kind of how we as workflow people like to represent them. There are many hidden steps in the process. There are lots of things that you don't actually see represented in a diagram. And it's also the scientific process is in very iterative and exploratory, right? You try and do something, you realize it's not working, and then you sort of take a back step, then you take 2 steps forward, then you take 1 step to the right, you talk to a colleague. There's a lot of those things that happen which are not captured. There's also lots of artifacts outside of software code, right? Notebooks, and it's very important. The room was to say, hey, we will be in hip deep water and there is no cell phone connectivity there, right? We actually had to have our user experience person show up on site and sort of go, oh, nothing we designed is going to work here, right? How do we actually build the right tool here for them? In addition to that, one of the other things is the collaborations have large complex stacks, and often they're looking at the least common denominator that's going to work for everybody, right? So it doesn't matter that there's the latest and greatest Python version, whatever, because that doesn't work for everybody, right? So they are going to stick to the base minimum that's there. But the biggest learning, I'd say, for us was new work practices of software that don't fit into the current mental model or work process will likely not get adopted, right? It's something we have to remember that, if we try to build a new greatest thing to do, that may not get ever adopted, right? So in 2012, after the retreat, we ended up writing our first proposal suggesting that we would do usability testing for workflow concepts and tools. I had a very simple plan. I was going to have there was somebody there who knew how to do usability studies and UI design. We were going to use her. We were going to build the tool. We were going to do some usability studies, and that's it. Oh boy, was that wrong, right? That's where we ended up having a nice UX team today, right? So what we realized at that point was we were looking at API usability, and there was very limited literature out there. I really thought everybody else had solved this problem, right? And I was just the new kid on the block who could take it. We also realized that when we looked at the methods in industry, a lot of them didn't work for us because scientific users were different. They were expert users, but also the rules in the system and in the ecosystem were not as well defined, right? There is often a scientist who is trained in chemistry who is writing code, because if they don't write the code, they cannot do their science, right? So they aren't a software engineer by training, but they're software engineer because they need to do their work, right? Which makes this very different. We looked at academia, and I've learned a lot from academia and sort of the social practices and looking at CSCW and stuff like that. But what we realized that there was a lot of framing over scientific software, but often we didn't really know how to take that and sort of take that theoretical understanding and convert it into action. So I did what I could do best. I just hired Charlotte students to come work for me. And so in some sense, what we've done is we've taken a mishmash of what we needed from both sides of the camp and made it work and evolved these techniques as we've gone. So our user research process, none of this will look new to people who do user research, but we do a lot of discovery and exploration, which is interviews, contextual inquiry, observations, competitive analysis, and things like that. We do some synthesis, journey maps, scenarios, design constraints or considerations. And then we also look at design, which is wireframe, detailed mockups, prototypes, APIs as well. And then we look at usability tests for interfaces and APIs, and how do we get people to give us feedback on what we've built. I'm not going to go over this list, but user research has been shown to have a lot of benefits for software. I strongly encourage everyone to take a moment to think about it, but it is very important, and I really hope people adopt it. So what has ended up happening over time is, I'd say we have sort of three focus areas in my team looking at UX. One is the more design plus development. I've listed some select projects here, which is, I'd say, much closer to what industry does, where we often do some user interviews and usability tests to understand the needs, but we keep in mind that our users are expert users, and sometimes the concepts are not always clear going in. So it's a very iterative process, right? It's not like I build the Google UI and I'm done and I can come back 5 years later. It's often sort of iterating every month even. The next set of projects has been sort of a line of projects where I would say they were really computer science projects, where we had a UX research team sort of be part of the team, where we built a lot of understanding around software, workflows, and data. And these tend to sort of go at deeper questions around what users need and want and what they need to do long-term and things like that. We've actually ended up in a place where often our next research project comes across from what we learned from the user research on the previous project, right? So we built sort of workflow templates, realized data abstractions were a big challenge. So we went to data challenges and looked at sort of data change and things like that, and then reproducibility, and then more interactivity, and sort of how to build that. In the last few years, we've started exploring, I'd say, much more longer term questions, which has resulted in a few key projects. One is a sort of a partnership with a high performance computing facility, looking at what the role of UX UI is in their ecosystem and what their UX UI and software strategy needs to look like. Strudel is actually funded by Josh from Sloan, and we're really looking at the UX UI in software, looking at typology of software and looking to see how we can make UX UI accessible to a larger community beyond the traditional roles that people have had for those. More recently, we've had a funded, DOE-funded seedling looking at software sustainability, which is part of a 6 seedlings that have just been started. And that's sort of a DOE-wide thing, looking at what does software sustainability look like in our environment. So in that respect, I'm going to sort of move on now to sort of tell you a little bit more about software and sort of what I've learned about social practices and scientific teams, which will hopefully set the context today. So I don't need to tell anyone here, science, we've effectively had computation and data become a main pillars of science, which means software has evolved and become a key part of the scientific ecosystem. we need software to work well for science to be done in many of our environments. And as we enter an era of autonomous discovery, where you see more automation at user facilities, which is whether it's robotics or whether it's more AI in the algorithm design and things like that, software only tends to become more and more important. So how do we frame scientific software is something we really need to think about, right? In industry, software is often the outcome of the effort that's being put in. So a lot of the planning and organization tends to be around those constructs of software, right? So you may see an organization which is search, right, at Google, or you may see something around, one key feature in search or something, right? So it's software is where it is structured, but that isn't necessarily true for us. And so we need to think about how we construct this and how we think about it, because in the end, the scientific environment, the publications and the science results are the ultimate outcome that we're all aiming for. The software ends up being a byproduct. There has been a framing around software in an instrument, which is true. We need to think of it as something that needs to be managed and maintained, just like an instrument. But instruments have a fixed lifetime. Software often doesn't have a fixed lifetime, and it does tend to evolve over time or get repurposed. And there's sort of this legacy things that you carry on, right? This is the reason we still have a lot of Fortran codes, right? Because it's really hard to rewrite these in a new language. At the end of all of this, what I like to sort of emphasize is software requires ongoing usability and user experience improvements so that they are reliable and a sustainable resource for user communities. So we believe that democratization of skills is critical for future software. So hear me out here, right? I just made something which might be a little controversial because people are start to feel like when I say this, they're going to lose their jobs, right? So the composition of teams that we have in scientific software are very different from industry in the sense that we often have software evolve from single-person teams. You have a graduate student or an early career professor who builds software, does research, and sort of, has this sort of is the champion, right? Like does everything. Often what happens is then the software dies when the student graduates when their research is done, or it gets passed on and we're sort of moving this along. But they have no experience doing UI, UX, understanding the users. And maybe they don't. If they're the single user of it, they don't need to do anything more, right? But if this keeps getting passed on from one user to the one graduate student to the next, there has to be some sustainability of software in place. They don't learn the skills to do software sustainability, right? They barely, at this point, we've reached a stage where a lot of people do learn to code in grad school or undergrad, which is great, right? We are making progress. Then you go to small teams and you have a small team of researchers, and you sometimes have this one person who's figured out that they really like programming. They may have a science background, but they really like programming, and they just take it on and they start, living and breathing and sort of become this expert in software engineering, right? And they pick up all the skills they need to. As you go to medium teams, usually, this is where our teams work a lot, is you have a team that's figured out that, there's what they need is beyond what the capabilities they have. So they have a part-time or a full-time CS person or a UI person on board to help them, right? And it was interesting because I did see that on Vani's slides as well, right? You have one person mapped per research domain to some extent. And as the large teams develop, the UX, UI, or the software engineering teams don't actually grow. They tend to be still one person, right? The other parts of the team grow, but they still tend to be one. So what happens is scientific teams are often resource constrained. There's limited funding. And so the composition of these teams and how they're funded makes a difference in how software is managed and maintained and developed. And we need to think about that in our sort of framing of software sustainability, right? And so let's think a little bit about what's made programming more mainstream for some of these people, right? There's a simplicity of tools. Everybody now pretty much knows how to go find a Python tutorial. They know how to use Jupyter notebooks. They can sort of go in and jump right in and start writing the code they need, right? So from a UX UI perspective, we are at this point where we really need to think about, can we do zero code or no code tools for this? Can we develop some UX methods that people can follow for basic stuff, right? So what I really want to happen is everybody is doing some level of software sustainability and UI and UX, but we then have people who are, for example, in this room, who are much more solving the bigger challenges, right? I really want my team to be able to solve the big problems, not the little problems that somebody else can be taught to solve, right? So in addition to that, I've gone through a little bit of this, but I do want to talk a little bit about software design styles, because I do think this impacts how we think about software and the social practices around it, right? There's a continuum of design decision styles, and I don't believe one or the other is right or wrong. Many of our software tools in scientific software starts out with unintended design, right? There's this graduate student who basically says, I need to do this thing. I'm going to write some code today, and I'm just going to use it once, right? But often it has unintended consequences because you start writing for something, and the next day you write something more, and then 3 months later you have a software package, right? And we don't really think about software sustainability. We don't teach people to think about user experience or software sustainability in the unintended design stages at all, right? Then you have the self-design where you are actually, no, you are the only user and you're just going to design it for yourself, right? And most times, I think that's true of a lot of scientific software in small groups where it's just very designed for their particular challenge. Then there's the genius design where, you're an expert in a specific topic and you can foresee exactly how a user might use it in a small set of circumstances, right? And you are really good at it because all the users are going to be exactly like you. So we call that genius design, right? That is mostly true for some scientific software, but not always true. Then there's the activity-focused design, where you focus on a set of activities and design the workflow for that specific set of activities. But this often hinders future innovation, right? Like, what do you do when the activities have changed? What happens beyond that? So user-focused design, I don't have to say it to this group, is really what we want to aim for, right? Where you sort of have the user in mind starting from the beginning. And also we have to remember that something that might start as self-design ends up being a community software. And how do we make that transition? And we don't really understand how to do that today, right? How do we get it's a lot of putting little things together. And I'd say it's very ad hoc right now. And there aren't sort of well-established practices to do that. So a lot of this work and thinking is effectively what has led us to the Sloan-funded project we're calling Strudel, because we like food items in our group and we really want to keep that theme going. And so what we're trying to look at is sort of say, can we come up with a software typology where we take the user workflow characteristics, the team characteristics, the user characteristics, and sort of come up with this typology, which will help us then build a UI UX design system where people who don't build UIs today can have some starting point where they can sort of take these templates and then build on it. And it's, our eventual goal is to be low code, no code. We're not going to get there anytime soon, but at least give them a framework to start from, right? And so a lot of what we're doing today, and I'm going to skip, I'm looking at the time here, I'm going to skip over some of the details, happy to talk about it during the breaks, sort of looking at various aspects of scientific work. We look at team characteristics, we look at user characteristics, but we've also more recently been looking at sort of, what are they trying to address? What happened before the software existed? What are the milestones? How do they deal with the milestones? How do they approach the UI development? What was success like? How was their approach to software sustainability? No surprises, nobody had a software sustainability plan when they started out, right? And then what is their approach towards community engagement? And I'm going to come into this one a little bit more a little later in my talk, because we do believe this is an essence of sort of measuring success of software long term. So in terms of sort of the design system itself, I just have a quick slide here to show you that, our team's been developing these UIs for many projects over the years. And we basically came to the conclusion that there were sort of end patterns, and, we were just doing UIs for these end patterns again and again, right? So there's scenario selection, there's selecting inputs, there's a dashboard summary of results, and often there's sort of history and things like that. There's a few more patterns, and I'm not going to go into that today, but it is, if we were able to provide some basic tools, you have a UI toolbox that you can then use to develop UIs quickly. So I think I've established by now that scientific collaborations are complex and that it's very mushy how people interact with each other. I have this quick slide here to show how most of the interactions happen right now, where you have a software sustainability team sometimes, and that's usually either composed of software developers, engineers, or they work very closely with them. We actually have people in our team who do software sustainability who are different from the software developers and engineers, but they only sort of interact in this space. You have the community engagement team in large science projects, and they do interact a lot with the science users, and they do UX without knowing it's UX in some ways, but they also do other things where I think UX could really help them, right? So they're the ones who end up interacting with the users and finding out what they need and things like that. More recently, at least for the projects that we are involved in, we have a user research team that sort of talks to both the science users and UI developers, and sometimes also the software developers and engineers. So they sort of sit in that realm, right? But there's a disconnect here, right? We want eventually for the community engagement, software sustainability, user research to really come together to make a difference. So we've been thinking about this problem in the last, I'd say, a few months or so. And we did take a peek at industry, and it's useful because I just was able to hire someone back from industry. So we had a little more visibility into the structures. And those of you from industry can tell me if this picture is wrong or it's different in some other places. But often what they do is they have, sort of the engineering division, and then they have a product management division, and then they have a UX division, right? And usually one UX division, some number of product management division map to many engineering divisions, right? So for them, it's much more hierarchical in structure. So, you can see that as you go up the chain, there's communication happening between the teams. So they also think of software as a product. So they are sort of, making this work in that way. Our sense is that wouldn't work in our environment because we have a much more collaborative structure. And so we sort of believe that eventually we really need to figure out how to bring these three teams together and bring the sort of ecosystem together in a way that we are thinking about user experience and software sustainability and why that's important. All right, according to this here, I have 45 seconds. I'm going to try and keep it to that. So, if you want to take away sort of a couple of things from here, user experience and software sustainability are closely tied to ensure successful software. This is a little bit difficult because sometimes you have to start thinking about software sustainability or user experience before you actually have real users. And if you don't have real users, you can't go get funding, but you can't do any software sustainability till you have funding. So it's a little bit tricky. User research processes definitely improve the outcomes. I think our group is an example of how our outcomes have definitely improved, both in terms of how we think about research, but how we think about software as well. From our perspective, we have some future questions. What's the right framing that will let us think about software sustainability? It's for us, the instrument framing doesn't seem to fit for the kind of software we work with. There's probably other literature. We are sort of looking at that and trying to come up with the right framing. How do we democratize user research and software sustainability principles? I think a big question here is also, how do you measure the success of these, right? Because, in the end of the day, whether I'm reporting to a funding agency or to my management structure, they want to know, how was this successful, right? What's this metric of success? And that's definitely a question that we keep asking ourselves, because I don't think it's as simple as saying number of users. I don't want to say it's number of users, right? It's the quality of the experience. How do we organize and structure these teams to ensure great software outcomes? And how do we build this community, right? I think this workshop is a great example of bringing community from different backgrounds, but I think we need to do it at a much larger scale. And how do we scale some of these methods so that everybody can use them? Thank you. And I couldn't have done this without funding and my awesome team. I'm just the face that stands here trying to summarize a lot of work that's been done. I'm ready for any questions people may have.